These are three simple tricks you can use to identify the horizontal asymptotes of a rational function. A little warning, in this video, I'm only going to be explaining how to apply these tricks, but not actually demonstrate why they work. So if you want to understand these more in depth, I'd advise you to look up other YouTube videos that explain these methods more in depth. So here we have a rational function, right? And we have to find the horizontal asymptote of this function. So when we're talking about the horizontal asymptotes, we're actually talking about the end behavior of a function. The end behavior refers to how the function behaves as x approaches positive infinity and negative infinity. So since we are analyzing the end behavior of a function, the end behavior of a function is actually defined by the degree of the function. So we're going to have to compare the degrees of the numerator and the denominator. So in this case, the degree of the top is 1 and the degree of the bottom is 2. And since the degree of the top is less than the degree of the bottom, then we have a horizontal asymptote at y is equal to 0. Our second type of horizontal asymptote occurs when the degree of the numerator and the denominator are the same. And as you can see in this case, the degree of the top and the bottom are both 3. So in this case, our horizontal asymptote is actually going to be a division of the leading coefficients. More specifically, the division of the leading coefficient of the numerator divided by that of the denominator. So then we take 7 and 14, we divide them, and we get that our horizontal asymptote is at y is equal to 1/2. Our third type of asymptote arises when the degree of the numerator is exactly 1 higher than that of the denominator. As you can see in this case, the degree of the top is 2, while the degree of the bottom is 1. So in this case, we're actually going to have what is called an oblique asymptote, which is also known as a slant asymptote, which is this asymptote that is diagonal like this, instead of being, completely horizontal. The equation of an oblique asymptote is y is equal to mx plus b, where we have a slope m that is not equal to 0, and where b is the y-intercept of that line. So finding the oblique asymptote is actually very simple. What you want to do is you want to divide these two fractions. In most cases, you have to do polynomial long division, but in this case, I decided to do synthetic division right here, and I ended up with f of x being equal to 3x minus 6 plus the remainder 19 divided by x plus 2. And actually, our oblique asymptote ends up being y equal to this part right here. This other part here, we can just ignore it. We can throw it away. So this is our horizontal asymptote for this rational function. Something important to note is that when you do your polynomial division, if the remainder of the division is equal to 0, then that means that there are no asymptotes of any kind. This is because, think of it this way, if there was no remainder here, right, then this would actually simplify to a linear polynomial. So a linear polynomial doesn't really have asymptotes. It might have a couple discontinuities, right? But a linear function does not have any asymptotes. That's why it's really important for you to simplify your fractions before you actually start to find any horizontal asymptotes. Just remember these three rules, right? If the degree of the top is less than the degree of the bottom, then we have a horizontal asymptote at the line y is equal to 0. If the degree of the top and the bottom are equal, then we have a horizontal asymptote at the leading coefficient of the top divided by the leading coefficient of the bottom. If the degree of the top is exactly 1 greater than the degree of the bottom, then we have an oblique asymptote.